Welcome to lesson 30. What we're doing is we are doing what I told you always that you can't do. I've always said you can't really have decimals as part of a fraction. And this is going to explain to you why that's both true and false. So when you look at these, what we've got going on here, here's one that's already done. Here's 2 and 4/10. And what you're used to seeing with 2 and 4/10, let me go off yellow so we can have a nicer color than that. I'm going to go blue. If we have 2 and 4/10, the way we've looked at it has always been 2 and 4/10. But what they've got going on here, see, they've just kind of put it right into the fraction. 2 and 4/10 right here, divided by 8/10. So this, if you read it out loud, it sounds exactly the same. 2 and 4/10 divided by 8/10. 2 and 4/10 divided by 8/10. And here's why this is right, this is wrong. Actually, this is kind of wrong too, isn't it? Because there's no whole number there. Here's what we do to make sure that this all stays clear. This 4 is in the tenths place. The 8 is in the tenths place. And you know how it is. If you have 10/10, you have a whole. So if I say 4/10 times 10, all of a sudden I have 40/10. If I take 8/10 and multiply it by 10, all of a sudden I have 80/10. So it overflows into the ones place. The 4/10, the 4 goes from the tenths place into the ones place because it overflowed. The same thing happened to the 8. So now when we look at this, when we read it from the top down the way we have been as a division problem, 24 divided by 8. Well, we know that 3 times 8 is 24. So the answer is 3 times. So when you're thinking if it's $2.40, how many pieces that are 80 cents each? If you have 3 sets of 80 cents, you've got $2.40. Now let's look at, I'm going to scroll on down, and we're going to take a look at both G and H. Here's why. We have a 4 and a 5 divided by a 1 and a 5. Here's a 4 and a 5 divided by a 1 and a 5. And we can see here we have a 5 in the tenths place, a 5 in the tenths place. In this case, they moved that 5 to the hundredths place. So it'll be interesting because they've both moved the same amount. So in this case, if I have 4 and 5/10 divided by 1 and 5/10, get my decimal clear, and I multiply by 10 because I want to move and grow the 5 by 1 decimal place. So I'm going to multiply by 10. Let's do the same thing to the other one over here. We have 45 hundredths divided by 15 hundredths, and because it's in the hundredths place and I want to move it to the ones place, 100 100ths is 1, so I'm going to multiply by 100 in both cases. So it's also the same as multiplying by 1, right? 100 over 100 is 1, 10 over 10 is 1, so it's not actually going to change things for real, be the same on both. So now it's going to grow by 1 place value and become 45 over 15. This one is going to grow by 2 place values. So that 5 is going to be in the ones place. The 4 will be in the tens place. Oops, my plate just slipped. 45. 45. And then the 5 in this one is going to go in the ones place, which is going to make the 1 in the tens place. Look, we ended up with the same thing. 45 divided by 15. 45 divided by 15. Now I know on a clock that 45 minutes is divided by 15, that there's actually 3 sets of 15 in it. So the answer to both of them is 3, because they changed place values evenly. Now we're going to look at one that's a little bit different. So this one, your 4 in the tenths place goes to the hundredths place. Your 2 in the tenths place also goes to the hundredths place. So let's not do that one. That one's going to be the same. Let's think about Let's try this one. A restaurant's salt shakers contain 6/10 of an ounce of salt, each one. Its large shakers hold twice as much. The shakers are filled from a container that has 18.6 ounces of salt. 8 large containers are filled. How many small containers can be filled then with what's remaining? So we know that 8 large containers, that those ones actually hold twice as much as 0.6 ounces, 6/10. So what we have here is 6, when you double it, you have 12, right? And so it's going to be 1.2 because 6 plus 6 is 12. It overflows and goes into the ones place. And now we're saying that times 8 to figure out how much salt the large containers will use, and then we'll find what's left for the smalls. I know 8 times 2, 16. 8 times 1 is 8 plus 1 is 9. We had one place value that's in the decimal in the problem, so we have 1 that's in the decimal in the answer. Now we have to find the difference. If we had 18.6 to use, and we have used 9.6 or 9 6/10 of it, we know 6/10 minus 6/10 is nothing, and 8 minus 9 is 9. So it's 9 whole ounces. We have 9 whole ounces that we're going to divide by the amount that a small container uses, which is 6/10. So when we think about this, 6/10 goes into 9. 9 divided by 6/10. Let's do something so that we can get rid of the decimal. So I'm going to multiply this times 10 to get rid of the decimal, but it means I have to do the same to the other number because we have to treat them equally. So this becomes 90 divided by 6. 6 goes into 9 one time with a difference of 3, and then you bring down your 0, and I know that 6 times 5 is 30. So we can have 15 small shakers. Oops, make the S first. Small shakers. S-H-A-K-E-R-S. Small shakers filled. So that's your answer. So for homework tonight, let's take a look at the exit ticket. Here it is. I'm going to ask you to just simply do B. Do this one for your homework. 8 minutes. Yay! See you tomorrow.